Good morning. Now we can see the term electric field intensity. Electric field intensity, it is a vector quantity which is represented by the letter E. It is also called electric field strength. That is the force that is defined electric field intensity or electric field strength, which is defined as the force per unit charge placed in an electric field. That is, electric field intensity is the force per unit charge placed in an electric field. Its unit is Newton per coulomb. The unit of force is Newton and unit of charge is coulomb. So its unit is Newton per coulomb. Volt per meter can be also a unit of, that is also a unit of electric field intensity, volt per meter. Okay. The equation, we know the equation of force using Coulomb's law. And that equation of force divided by Q will give the equation for electric field intensity. So the electric field intensity equation E can be written as E equal to 1 by 4 pi epsilon 0 Q divided by R minus R1 the whole cube magnitude into R minus R1 in the vector form of electric field. This much Newton per coulomb. Here, this equation gives the electric field intensity at a point R due to point charge located at R1. Okay, that is, this equation gives electric field intensity at point R due to a point charge located at the distance R1 from the origin. Okay, next we are going to see the different charge distributions. Here, there are 4 types of charge distribution. First one is point charge, and the second one is the surface line charge, and the third one is the surface charge, and the fourth one is the volume charge. First one, we can see what is point charge. Point charge. The point charge can be told as, if a charge is a point charge, if the dimensions of the surface carrying the charge is very small compared to the region surrounding it, then the surface can be treated as to be a point. Then in the surface, that charge can be treated as a point. So it has position. The point charge has only position, no dimensions, because it is very small. That is a point charge. That is very much small compared to the surface covering that charge. Next one, we can see what is line charge. Line charge. If a charge is spread all along a line, that line can be finite or infinite. Such charge is called a line charge, that is uniformly distributed along a line. Okay, that line can be finite length or infinite length. Okay, for example, if the charge conducting wire can be treated as a line charge. Here we can also see a term line charge density, which can be expressed as rho L. Rho L is total charge in a line in coulomb. Total charge in coulomb divided by total length of a line. Total length of the line. Okay. So line charge density can be expressed as coulomb per meter. See, rho L can be expressed as dq, charge change in charge is dq, small charge dq, and length is taken as dl. Then dq can be expressed as rho L dl, or in this case rho L dl. In this case, q can be found out by integrating dq over the length L, that is equal to integral of rho L dl. This is about line charge. Next, we are going to see what is surface charge. Third one is surface charge. The perfect example of surface charge is a charged metal plate. We can see that is a surface charge. If the charges are distributed uniformly over a two-dimensional surface, then it is called a surface charge. The surface charge density can be denoted by rho s, which is equal to total charge divided by area, total area, this curve, that is equal to total charge Q, that is dq divided by area, that is surface area, ds. So dq can be expressed as dq is equal to rho s ds, or q can be expressed as integral of dq, which is equal to surface integral of rho s ds and surface. And this is about surface charge. Next, we are going to see the volume charge. Fourth one is the volume charge. Example of volume charge is a charge sphere. If the charge is distributed uniformly in a volume, then it is called volume charge. Volume charge density can be denoted by rho v, that is equal to total charge divided by total volume, that is can be expressed dq by dv, or dq can be expressed as rho v dv, or q, total charge q is equal to integral of dq, which is equal to volume integral of rho v d. This is about the volume charge. Okay, thank you.